this part, we are going to have a look at how to create an array from a list, how to create specific arrays using the functions of NumPy library, some special arrays, then creating also arrays with number content, random content, so random numbers, using the random module from the NumPy library. So now that we had a quick overview of what we are going to do, let's jump onto our new Jupyter notebook and let's get started. First, let's start by importing the NumPy library as NP. This is actually from the convention, it's called like this, it's popularly used like this, or it's NP is short for NumPy in this case, makes it easier to call it and use it. Now that we imported NumPy as NP, we can define a list to see how we can create an array from a list. So let us create list with 1, 2, 3. Let's display this list. And then let's create an array 1 using this list. And this we will do this by calling the array function from the NumPy library. So how we do it is we use this name, we called it by np.array function. Then we give in our list. And then we display our array 1. And as you can see, we just created an array from the list. And we can see that because it displays here that it's an array. Now, but if we wanted to create, for example, an array from combination of lists, let's define a list 2, 10, 10, 11, 12, 13. Then let's display this list 2. Now let's combine these lists in a compilation list. List 1, list 2. So this is a combination list holding 2 lists inside. Now if we display our combination list, as you can see, so we can also create an array of for example 4 by 2 in this case, so it will be a 2D array. Let's say combination array. So it does not matter the size of the list you pass in, it will convert it to an array without problems. Now let's display, and as we can see, now we have an array. Now let's check the data type in our array. As we can see, they are all of type integer. So we have all integers inside our array. As we've said, it's not possible to have different types of objects in an array. Moving on, what else could we have? We could also have floats, strings, voids. So these are some possible data types that we can store in an array. So let's, for example, if we want to convert these integers to a float and store them as float, how would we do that? We will do that by saying, let's create an array exactly like before from the combination list, but this time we can also specify data type, float. Now, we've talked in the Python section that some optional parameters we can give if we want to overwrite it. So if you don't specify any data type here, then it would actually recognize automatically itself what kind of a content inside this list is, then it would store it as that. But now that we are saying that store it as a float, then it's going to convert them into a float and store them as a float. Now we can see that they're all floats. Now let's have a look at how to create arrays of a specific type. For example, we can create arrays which only have zeros inside. And this is with the zeros function from the NumPy library. We call this zeros function, then we give in how many items do we want to have in our array. And then we press Shift Enter. As you can see, we have all zeros in our array. Now, what if we wanted to have an array of a different size, but again with zeros? Then let's say zeros, but this time we are going to pass in a tuple with the size. So we are going to say, for example, 5 rows, 2 columns. And let us assign this to a zeros array so that we can use it later on. And then displaying this zeros array, as you can see, now we have an array of a different size. Here it was only just like a one-dimensional array with 10 items, but here we have an array with a specific shape that we gave in. So 5 rows, 2 columns, all zeros. Now let's check the data type of our array. And as you can see, it's of float type. So zeros creates arrays with zeros but of type float. We can also assign a different data type if you want. If it doesn't make sense to have floats for zeros in the array, you can say zeros array as type, then we specify what we want to have. So integer. This is actually the data type from Python, integer, int. And then you press Shift Enter, here we go. All of our items are now integer. We can also create an array of only ones, for example, not zeros but ones. And this is with the ones function from the NumPy library, np.ones. Now we have to again pass in a tuple indicating the size. For example, let's say 2 rows and 3 columns. As you can see, we have with ones 2 items of float type, data of float type, 2 rows, 3 columns, all ones. We can also call the empty function, empty, and let's pass in a tuple indicating the size, 3 rows, 4 columns. Now, as you can see, we have all zeros here. If not zeros, we have values very, very close to 0 here. For example, in the first item here, we have a value very, very close to 0. So if we were to round it, it would be actually equal to 0. So it's also possible to define not with zeros, but with empty. Now, let's check out the data type in this. Oh, not without the parentheses, because data type is actually an attribute. Exactly. As you can see, they're also floats. It actually had a different way of showing them. It actually showed them like with this exponentiation format, like logarithmic values, but anyways, moving on. We can also create arrays with all ones in the diagonal, and this is with the I function. as we can see, we've created a matrix of 5 by 5 with all ones on the diagonal. Here we don't need to give using a tuple, for example 5 by 5, because to be able to have a diagonal matrix it has to be with same rows and same columns, of course. So just giving one size is enough. It's going to automatically create rows and columns of that size. What else? How else can we actually form arrays? You can actually form arrays within a range, and this is using the arange function. Arange, and let's say 5. When we give in 5, it's going to automatically start from 0 and all the way until 5. Create an array with content from 0 all the way until 5. Can we not specify the start, or for example the interval that it's going to choose the value? So we can say start from 5 until 10 and choose every second value. And as you can see, you can also specify start and the interval. You can also specify an array using the linspace function. This creates an array of linearly spaced numbers, so equally spaced numbers. Here we give in starting from 0 until 5. Let's say we want 11 evenly spaced numbers. Let me press, this is supposed to be space. Now when we press shift enter, we can see we have linearly spaced, so with equal spacing, equal intervals, 11 numbers. It's also possible to create arrays with random content, so random numbers inside. This comes in very handy when we want to generate a big array or big data sets which we want to play around with, and when we don't have any data set on our hand and we just want to play around and test some functions, then this comes in very handy. So let's have a look at it. First, we need to import from the NumPy library the random module, and let's call it RD, so that's easier to use it. Now, what if we wanted to create an array with 10 random floating point numbers? Then we were to call from the RD module rand function and specify that we want 10 numbers in our array. Then double dot, not here, single dot. And then we have an array with 10 random floating point numbers inside. We can also create from the RD module random integers, so a random array with integers inside. So this is why rand int function. This time let's specify to start, so from 2 to 5 until 5, and let's say 10 numbers. In this case it means we want 10 numbers, and this can be anything from 2 until 5. Let's enter. As you can see, we have, for example, 2s, 3s. This is just completely random generated in this interval from 2 to 5. Now we can also create random 10 numbers with a normal distribution, for example. This is with rand n function. So random 10 numbers, rand n. As you can see, these numbers have a random distribution, normal distribution, and they are randomly generated. Now we can also use directly the NumPy module to be able to call this random functions. So from this random module, the random functions. How would we be able to do this? Let's say array and assign. We can call off of np dot random dot rand integer. So rand int from 0 until 10, say 10 numbers. So what is going on here? Here it's going on into this NumPy library, which is called np. We just imported this in the beginning. Then it's going to go into the random module and call rand int function off of it. And with this method, we don't actually need to import random again with this line. So this is also another option. If we were to shift enter and display our array, as you can see, works perfectly fine. And we can also reshape our arrays. let's have a look at it. If we were to say, if we already generated an array, but we want it to be a different shape, then we can quickly reshape it. Reshape. And let's say we want to reshape to 5 rows and 2 columns. And then let's display our array again. Oh, something did not work here. Oops, we did not assign it to our array here. Okay, here we go. We forgot to assign the new array to the array, so it did the operation, but then it showed the old array again. So when we assign it back to this array, then it's going to modify. Then it shows the modified version. Sorry for that small mistake. So now that we are done with creating random arrays, we can go back, we can go on to do numerical arithmetical operations with NumPy.